So welcome to part 5 of the Rapidus 800XL, and I've done a little bit of work. I've been a little bit cheeky and I've done a couple of things while off stream to just make things move a little bit quicker. In the previous video we got the Rapidus to work with the Ultimate 1 MB already in the machine, and I tried a side cartridge quickly as a quick test of stability towards the end of the video, and encountered the problem of the hard disk not being recognized. But what I think we'll do is we'll ignore that for now, and we'll press on and get the rest of the upgrades into the computer and try and troubleshoot the stability issue as a sort of a finale to the whole procedure. So what I've done in the intervening time to try and save a few moments in this video, just started by Restream IO, so that if anybody happens to write anything down I can see it. It hasn't done a forced update today, which is great, and I will remember to try and speak as clearly as possible, because I noticed in the last video towards the end of it the audio seemed to drop off a little bit, and I thought there was some problem with the batteries perhaps, or something along those lines, but no, everything seems to work, so it must have just been me. Audio should be on both channels. We're streaming at 5 megabits and everything should be just fine. So what have I done in the intervening time is, as you can see, I've took some things off. What I did is I added a, not a very good screwdriver, I added a socket underneath 74 LS08. Come on. There you are. So I got a nice socket here. You can't really see that, can you? There. Now the chip hasn't changed, it's the same chip, but the idea of this is that if we hit problems later on with timing, it'll be easy to swap this chip out, just as it'll be easy to swap out the CPU. So that's just a potential time saver for later on, and I've cleaned the legs of this IC of solder, but it's still a little bit tricky to put back in the precision socket. Just straighten the legs a little bit, and hopefully it'll drop back into place. So I did that, socketed that chip for later on. I've taken the external select jumper off the board, because I need that signal as well for the VBXE, so I'm going to twist those two wires and send external select to the VBXE as well. So I thought I'd leave that until the video. The other things I've done is I have fed this cable here, which is our RGB video cable, which carries ground, red, green, blue, and RGB switch for SCART displays, and I've fed that through the hole that used to belong to the RF modulator. There's a slot here for the lugs that used to pass through the board to secure the RF modulator in place. Rather than drilling a new hole, I wanted this little ribbon cable to pass under the board, because it's going to travel turn everything over without everything falling off. It's going to travel here, and it's going to match up with these little pins on our jack, and through one of the other little holes that's left from the RF modulator. Here are my stereo left and right audio wires. So I've done most of the, well, in fact all of the crimping required, because crimping is not something I enjoy, and so I've gotten it all out of the way. Now this is the I/O header on for the Ultimate 1 megabyte, which I've removed because we're going to work on the board a little bit down here to fit the VBXE. This wire here is the ground signal for the Rapidus, which, as I explained in the previous video, you can connect to an Ultimate 1 megabyte header. In this case I have connected it to SO. I can't remember whether that's the correct pin for the plug-in for the new BIOS, but if it isn't, we'll change it. The main thing is that it is active low, if you like, so that works because the SO signal is low by default, even with the old original BIOS. This middle wire here is the MO signal, which is going to go to our U-Switch when it eventually gets installed, and the VB signal on this shorter jumper wire here with a DuPont connector at either end is going to provide the decoding address for our VBXE. So what we will do first, we might as well crack on and get the VBXE installed in the board. And the first thing I'm going to do, which I should probably have done off stream, is connect the necessary connectors and headers to the VBXE board. Let's move my tools onto the other desk where I've got some more room. And why did I come over here? Ah, yes. Yes, I wanted to get another VBXE board just to remind myself of where the little connectors go. So I'll make a facsimile of it. This won't take long. So here's another VBXE board. This is actually dead. This is a board that I was given by an Atari Age forum member, and he'd removed the FPGA from the board because he couldn't get the thing to work for some reason. So I received it with no FPGA on it. Removed it with a hot air gun, so I eventually purchased a new FPGA and affixed it to the board, and it still doesn't work. But it's a useful ornament. The AVR light doesn't even come on in this thing, so I'm not sure what's wrong with it. But it appears to be beyond my capabilities to fix it. So what do we want in terms of headers? Well, we want a 3-way dual row header. If I can manage to break one of these things off without destroying the whole thing. Oh. Yes, how do I usually do this? There we go. That's how I usually do it. We've got a 4-way dual row header and a 3-way dual row header. The 4-way dual row header is going to go on to the J1 jumper. Just bent one of the pins, which is a good start. Let's unbend this. Put on our G1 header. Come on. You, what? You can't have soldering. No. There we go. Finally. Push that down so it's nice and straight. Back on the bevel tip. Some of these headers I'm putting on this VBXE really aren't used, but I like to have them on there anyway. I'm going to add flux because things aren't flowing too well on that pin. Becoming far too dependent on this flux. That's better. Yep. Now we add our G2 header. Actually, it's a little bit useful to bend the pins just a wee bit, and it helps the connector to stay in position. Well, obviously not in this particular instance, just because I happened to say it would. Solder on one pin, get the thing straight. That's good enough. Good enough. Okay, so there's our G2 header attached. And what else do we need? That's the end of the dual row headers. Do we need some? Yeah. I don't think I've got any of these ones now. Focus. 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 Is the autofocus even on? Yes, autofocus is on, so you can focus. There we go. So I don't seem to have any of these headers where the plastic is flush with the board, if you see what I mean. I don't think it makes any difference, to be honest. I'm just going to use these ones. So I need 2 4-way headers. So you don't have to add these. The board comes with none attached at all. If you want to solder wires directly to the motherboard, nobody's going to stop you. when you want to take the board out of the machine for any reason, just remember that it won't come out without desoldering those wires. Just going to tack this on so I can see that it's straight. Is it straight? Yes, it's straight enough. No, well, not quite. Straighten up. Yeah, that's better. Do the rest of the pins. Making sure I don't start with the one that I already soldered on the other side. There we go. Right, that's okay. And lastly, these ones here. Ah, there's nobody in chat. This makes me sad. I suppose the upside of no chat is that I get the work done. There we go. Now furnished with connectors whose value totals around 10 pence. Okay, so I'll put this back now. Don't want to get confused and put a dead board in this machine. Okay, now this board has, oh, if I can read it, 14.31818 crystal, 14.18. So the slower crystals on the NTSC side, and I believe that I'm here. Good evening from Germany. Good evening. Nice to have you here. Get my board. So let's have a quick look at the instructions. I fully intended to set up another camera, another monitor tonight, but I haven't really gotten around to it. But anyway, as you can see, we're going to remove R110, we're going to remove Q8, and the bottom leg of R110 is where we're going to put 3.5 megahertz in from pin 1 of J6 on the VBXE, and the top pin is where we're going to pick up ground on pin 4 of J6. and I take the crystal off the board as well, the top crystal, CO16112. So let's go ahead and do that. Yeah, it's going to be a lot easier with another monitor set up. Because, whoa, because it's just too crowded on here. I've got, hi Atari fan. It's just too crowded on this monitor, and when I want to capture the desktop, there's just a whole shitload of stuff that needs to be moved around. So this PC is on the desk I use for the soldering, and the other PC is on the desk that I use for coding, and I don't really want to have the coding machine with bits of solder all over it and stuff, or the monitors in particular. But this machine will run 3 monitors at a time, so I'm a little bit at a loss how to set things up, to be honest, for the best. But we'll just continue with the way things are for the moment. So we are removing the crystal, the master crystal for the system. Popped out without any trouble, and we're going to take off Q8, which is the lower transistor here. Let's try and make sure I take the right one off. The lower one, Q8, which is going to be down here. I think it's you. Yeah. Top leg, or should I say top leg, projecting so that you can hear. I don't know what that audio glitch was last night, but I didn't. Ow, 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 ow. No, I don't know what that was. There we go. And R110, which is that 220 ohm? I don't know. I don't know what it is. I know 220 ohm resistors have got 2 stripes, 2 red stripes on them, haven't they? And a brown one. I don't know. Come on. Over here, and extract you with the pliers. There we go. Alright. I'll just show you the part that we've cleared, because I'm aware I'm working at a distance from the camera. So there you go. We've got crystal gone, transistor gone, resistor gone. And where is our wire for the... There we go. here's our lead for the clock. That goes on this way. I think we'll trim it down a little bit because it's going to be far too long. It's only got to go from here to here. So let's trim you down a little bit. Not too far, but something along these lines here. So yes, stability issues behind. Somebody commented on the last video that he asked if maybe there was a problem with the cartridge port, which might have explained why the side cartridge wasn't detected at all, or certainly the IDE registers weren't detected at all when I tried them. That's a reasonable comment, because if it was a timing issue, I would have expected the hard disk to be recognized, but to get all sorts of I/O errors on, all sorts of transmission errors. But that's not what happened. So it remains a mystery for now. So it's going to ignore it for the moment. Refer to my instructions again. Something about Restream I/O chat is that it crashes every time the computer wakes up. If I put this machine to sleep and leave Restream I/O chat client open, it crashes every time it wakes up. I should probably submit a bug report. Right, so ground is on pin 4. Which is U, which is the top leg. That's perfect. If I get these the wrong way around, that's not a problem. Not a problem. Use my quirky blue tack method. Push these wires off the camera again. Push these wires in and keep them there while I solder them from the other side. I take it you're supposed to be a bridge. That must be ground, correct? Okay. Right, so there is the clock signal. Get you out of the way. Now for our next header, which is going to be attached this way on, because I try whenever possible to have the arrow on the connector aligned with pin 1, and pin 1 is at the far end. You can't see that, can you? Pin 1 is where the little square is on the silk screen. So my little arrow, where's my little arrow? My little arrow, which is, you can't even see that. Wrong side. Now it's too dark. Yeah, well, you'll have to take my word for it. There's a little arrow on the connector, so I like to have that correctly oriented. So J3 pin 1, J3 pin 1, what are you? Your IRQ, CPU pin 4, so let's get the multimeter and find out if we can find a nice hookup point for IRQ pin 4. We could just as easily take it from this adapter, in fact. There's a missed opportunity. This little header here, this little adapter's header, where you got your 4. I soldered a header on here, by the way, just in case I decided to use it. You've got phi 2, read write, reset, halt. You could have put IRQ on there as well, and then people with VBXE could have taken the IRQ signal straight from this header. Missed opportunity. Never mind. It's probably on one of these pins, but you know, you just have to. So I think the IRQ shows up on a bottom leg of a resistor, and I'm sure it shows up on, this is from memory, the right hand leg of R20, which is, I think, a pull-up resistor. Let's find out. I figured out that stability modification as well using the schematic. So if we need to use that, that's not going to be a problem. CPU pin 4. No, that's completely wrong. R20's got absolutely nothing to do with it. No, it has not. I remember picking up the IRQ signal somewhere on a leg of a resistor. Yes, it was this resistor here. That's the resistor it was. Yes, and it is the resistor. Oh, I can't read it. Is it R35, possibly? Make sure I get the right leg as well. It's the bottom leg of R35. So that's where we'll take the IRQ signal, the bottom leg of, I think it's R35. I think R35. Try and keep my voice loud so I can be heard. So that is the... oh, God. Try and keep track of these. Oh, it's still on here. This just quickly becomes a complete rat's nest of wires, but no mind. I'm going to try and route them as neatly as possible. So you go on that way. So they're going to travel down here. So you need to be about that long. Can I thread you underneath anything, or no? That's about there. That's fine. Ideal. Perfect. It'd be good if this camera was sort of more overhead, but I'd have to make some sort of boom thing. Let's see. Get this machine finished, and then we'll have a rethink of the whole setup. Okay, tin the wire. I'm going to bend the wire into a little hook. hook shape, shorten it first, bend it into a little hook. Alright, like so. And we're going to add a dab of solder onto the bottom leg of the resistor. I'm sure there are a couple of machines out there where I forgot to attach the IRQ for the VBXE, but they never came back yet. I don't think there's a lot of VBXE software which uses the IRQ, to be honest. It's for the blitter. I think it's for the blitter and nothing else, as far as I remember. So when you do a blit operation, you can pull the IRQs for sort of a completion signal. Or indeed handle an interrupt. Okay, so there is the IRQ signal. What's next? External select. Yes, pin 2. So this is where we're going to try and yes, this is where we're going to try and twist these two wires and take them off the same spot. So that's going to have to travel down here. We could at least make some attempt to route these things. We could put you under the end of that capacitor. That would be good. Let's thread you under the end of that capacitor. Keep you flat on the board. There you are. It's like threading a needle. Come on. There we are. Sort of run that. It's twisted. Never mind. There we go. So run that through this so it lies flat. That looks a bit better. And we are going to join up with this wire here. So we're going to cut the thing around about there. Vote for GUI on VBXE. It does look nice on a VBXE machine, but not because it I'm just going to pull that through temporarily. Not because it uses any of the VBXE core features, but one of the last things I've done, the most recent things I've done, is to laboriously detach the hardware specific graphics code from the sort of core of the desktop manager and delegated it to code running in RAM, which is just about at the point at which it is something you can call a driver, which means in turn that it can be replaced, and it can be replaced with code that will drive VBXE, and all the internal data structures of the graphics manager have enough bits in them to carry things like 16-bit color and things like that. So wide enough that you could do things in 32-bit. That's not going to push through there, is it? Why have I got to be so... This insistence on having to put wires through wires. So yes, you could replace the graphics driver if you could be bothered to write a driver for VBXE. But the thing that kind of puts me off that a little bit is the fact that you'd have to write a whole load of new resources. Ideally, you'd want to write resources that took advantage of the extra color. So instead of having 1-bit icons, I mean, it makes sense that you'd probably want to have 8-bit icons, 8-bit color, what have you. There we go, it's through. Right, excellent. Just needed to clean it out a little bit. So our twined wire, twisted wire, has gone through the hole, and I'm going to solder it on the other side. And the other thing that bothered me just a little bit was that the fonts for the GUI, which are also 1-bit, the VBXE blitter won't upscale that data. So if you see what I mean, if you wanted to render a font, assuming we were using a VBXE driver with the GUI, and you wanted to render a font in a different color, or let's say you wanted to render it in black. You wanted to render the font in black. Obviously, if you were running in, say, 8-bit color, so 8 bits per 1 pixel, you couldn't just use the blitter on its own to transparently blit from the font data onto the screen. You can't. It won't take that 1 bit and fill 8 bits, if you see what I mean. But then again, I thought about it a little bit more, and you'd probably want to upscale. You'd want to make multiple colored copies of the fonts on installation, which is, I think, what Symboss does to get around the overhead of having to recompute bit patterns, color bit patterns when rendering text. Is that it when it actually loads the font, it creates several copies, pre-rendered copies of the glyphs in different colors. So that's, I mean, it's not really a problem. I was kind of approaching the problem from the wrong direction, I think. But yeah, I mean, you could have, what goes on. I'm having to move the chat window just to get it to see what I'm looking at underneath. Right, ground, no, not connected. I'm not putting ground on pin 3. 74 LSO8, pin 10, CAS inhibit. And I think this goes here. I think you go here. So let's route you along the same path and take you along here. There we go. Yeah, you could theoretically, the GUI could look. I think it could run at 640 by 400, i.e. no, 640 by 480 I. So that would be an interlaced VGA resolution at 16 colors. So if we used Rybags interlace with 640 by 640 by 240, we could get VGA resolution at 16 colors, which would be pretty good, because the 640 by 200, things are going to look really, really poor. Whoops. Things are going to look really, the aspect ratio is going to be all wrong. So you'd probably want to run an interlace, and it would look pretty good. And it would run quickly as well, because we'd be using the blitter. But really the fun part of the GUI is doing everything with a software blitter and 6502. That's a lot of fun. Right, so there is our one header for the VBXE, and I think we can actually fit the board in now. I have to keep checking the position of this mic because it's got a habit of uncurling itself and gradually moving further and further away from my mouth. You see the volume just seems to have dropped. Is it because of the position of the mic? Testing. No, it's fine. It's fine. It's all in my imagination. You'll tell me when the sound goes wrong, of course. You would tell me. Right, let's stick the board in. It's a good fit. It's a good fit. There we are. Plug this in. Tuck this wire down here. Pretend that it's neat. We'll just pretend for now that it's neat. Come on. There we are. And our clock wire, which goes on that way, until such time as I find out that I've got it on backwards, it goes on that way. This is our RGB connection, which isn't going to do anything at the moment. Is this the right way up? No. Completely the wrong way. Oh, that's the wrong way up. Take this out. Sound okay? Good. Oh, bloody hell, that's tight. Damn it. One of these damned pins must have solder in it. I'm completely shit at making these connectors. Come on. Then. Get in there. Right. I think I've saved it. That's it. Right, we'll fold this under itself. Did I put a dot on pin 1? I did. Right, fold this under itself, pass it underneath the board, like so. Thread it through here and forget about it for a while. Come on. There we go. Right. You're through there, you're through there. Okay. I think we will also put the Ultimate 1 megabyte back on the board. Oh, things are going to come together quickly now. This is where it gets interesting. This is where it gets good. As far as once I've got this VBXE RGB header rigged up, showing what that looks like, it's not going to be easy because I don't have a capture device that will handle a 15 kilohertz RGB, so I'll just have to test it with a SCART cable, and yeah, I'll test it with a SCART cable and film it with a camera probably. But the actual, what's going on here? What am I? Oh, I've got, oh, shit. These are the wrong pylons. Bloody hell. Wrong pylons. This is another machine I've got pieces. Start again. Here we are. Yes, so I'll probably just film it with the camera, but unless something's terribly wrong, it'll just work. So I'm not going to worry about RGB output, stereo output for the moment. I'm just going to get the thing to work. I mean, we've still got to cut a hole in the back of the case for the jack as well. Still a lot to do. But I think the innards we can get finished tonight, possibly. Although it's 2010. We'll do what we can. Hope this still fits in the case when it's done. Oops. And this Adaptus Rapidus thing is very rickety. The kind of thing actually shipping the machine back could possibly dislodge it if it got a bump. A little bit concerned about that. I mean, all it takes is to pop the lid off again and push it back into place, but still. Right, so this is our stereo audio, and this is, oh Jesus, right, this plugs in here, this plugs in here, so this is our, as I mentioned before, this is that looks much better from above, if I could get the camera rigged up like that. Decoding address. I'll just loop that round there for a moment. This isn't going to win any prizes for neatness. And this is stereo select, so that's unimportant for the moment. And we can put the that was close. Oof. Yes, the header I've soldered on here crashes straight into the RGB cable. Should really put that in last. Remove that for a minute. Push the adapter back in the CPU socket, right, and then plug the RGB cable in. God, this machine's cramped. Right. Wow. Whew. Very, very cramped. Get you out of the way. You out of the way. Let's put you down there. There has to be a better way to route this thing. It looks awful. Anyway. Ribbon cables. Right. Ribbon cable here. Oh, bloody hell. In here. And yet another ribbon cable. There's going to be a whole video spent on tidying this up. Jesus. Right. Push that down. Alright. Right. Look at this. Look at this. Have you ever seen anything like it? We're still not finished. We've still got the stereo board to put in here. Whew. There's more white than green. See if it works. See if we just get anything. If we get nothing, then it's a regression. Where's the power jack? Some light tidying. Right. Okay, is it going to work? What do you bet it's going to... Yeah. Hi Atari, old school Atari 8-bit. I don't miss ribbon cables. I really don't miss ribbon cables now since we got serial 8A. Right. We get a light. See that? We get the flash. Watch the Rapidus. We get a flash. So do we get a picture? No. No, we don't. And the AVR light is on. Okay. What have I done wrong? Kind of expected. And what have I done wrong? What have I done wrong? What changed? So external select's being picked up from the same place. I bet that clock signal's back to front. It's got a funny feeling about it. Flip that round and see what happens. Okay, we get a light. And we get nothing. Let's not discount the adapter. Oh, who am I kidding? It's not the adapter. No, it wasn't that. Okay, there's the jumper on the correct position. It should work, or I'd say not much to go wrong with this at the moment. So we get a light, get an AVR light, and no picture. Ah! Get ready for this. Yeah. Where does this go? Yes. You go here. Let's pretend that didn't happen. Too many wires on this machine. There we go, and it works. When you plug everything in where it's supposed to go, it works. Ah. This is kind of what I was expecting. Yeah. Yes. Ah, yes. This is familiar. So what's different now from yesterday is that we've got the additional load of VBXE on board, which has changed the behavior of the machine. So are we going to have to do this external select mod, or what? I'm just going to get a keyboard and see how far we get with it. All sorts of awful memories coming back here. And now it boots. Just because I plugged the keyboard in. Or does it boot? Or does it just hang? Oh. Why do I even agree to these things? Oh. Try the BIOS. Oh, all sorts of crap. Oh. Yeah. So we can start swapping chips out and trying to figure out what's wrong. I do have a spare VBXE actually. I'm just gonna try the spare VBXE. Just to eliminate it from my inquiries. Where's the spare VBXE? Oh, you don't say I didn't put the... Oh. I didn't put the headers on it yet. Oh, no. Oh, no, I didn't put the headers on the spare board yet. Alright. Actually, I don't even know if this board works. I haven't even tested it. That's fair enough. It can't be a bad VBXE. It's got to be this stupid amount of cabling. But we'll... let's try a different CPU. Let's try a different CPU. Let's get my box of CPUs. Right, which CPU we're going to use? Take your pick. We're going to use a Mexico, or are we going to use... Let's try this one. But they... no, I really haven't missed this at all. I haven't missed it one little bit. Power on. Well, that's worse. It doesn't work at all. That's got to tell us something. Change the CPU, and it doesn't work at all. Let's try a different one. 14806. Try this one. Try you. Which review are we on? No, this one. Oh, it's nice. So the NCR CPU, certainly better than that, wasn't it? So let's just try something here. Unplug Rapidus completely. This is currently the best way of fixing instability on a Rapidus machine. Although it is a little bit aggressive. Right. Boots up, works. BIOS, fine, no problem. Yes. The usual. So we're going to have to do this. Yep. Unfortunately, taking this out and leaving it out is not a permanent solution. It's a solution, but it's not a permanent solution. So we're going to have to try and troubleshoot why Rapidus causes all the instability on the machine. Yeah. It's happening again. It's happening again. Why did I say yes? Why? I did a 1200 XL with Rapidus a year ago or so. About a year ago, maybe a bit less than a year ago, and it was a fucking nightmare. Absolute nightmare. And before that, the machine, here we go, boots. But it's boots in 6502 mode. Boots in 6502 mode because I didn't plug the header in. So, when the core is disabled, when the whole board's off, the system boots, plug the header in again. Okay, are you going to boot? Who am I kidding? You're going to lock up. Of course you're going to lock up. Standard behavior. What does the header do? The header, without that header present, the whole thing basically is passive, because the operating system won't boot the Rapidus core, and the Rapidus core is what's responsible for running the 65816. So at the moment the thing is in 65816 mode. So if I unplug that, we're just back to 6502 mode. And 6502 mode kind of works. But this 1200 XL that I did for someone in America, and it cost me one of my own Ultimate 1 megabyte boards just to get the thing to work, because it would only work with a candle Ultimate 1 megabyte board. It wouldn't work with one of the more recent white Ultimate 1 megabyte boards, and so I had to can you change the Rapidus board to another one maybe? Yeah, I could, because I've got a spare. That's a reasonable idea. I'll get my Rapidus board out of the spares box where it's been for the past year, and we'll try it. But because this board has the latest firmware on it, I would hope, the latest firmware which really alleviated nearly all of the problems that I'd encountered. And if that firmware had been around when I did that machine for the American guy, life would have been a whole lot easier, probably. I mean, who knows if he even updated the firmware. I don't know. But it wasn't around then, so I had to basically donate a board, an Ultimate board, just to get the thing to work reasonably well. which I kind of resented a bit, but it was my own fault for taking the job on in the first place, I suppose. Because even on, so that is the original one, keep that out of the way, because on Atari's page it says that he may refuse to install the Rapidus if the machine already contains other upgrades. It says that on the page, so the implication being there is that depending on, oh fuck, okay, scratch that idea, scratch that idea. I can't test my Rapidus in this machine because I replaced the 3-pin header with this thing. Come on, focus. I know it's getting dark, but so that is never going to happen. So it was a good idea, but anyway, the Rapidus can't be defective. Can't be. I mean, in fairness, all the Rapidus boards that I thought had a fault on them, they didn't. So we'll put this back. So where was I? I've got lost. I'm going to have to do this external select modification, which is going to involve messing up all my wiring. But before we do that, we will try replacing 74 LS08. If I can find a machine I might pinch one from, there's one. We'll try that, and if that doesn't work, we'll try the modification to external select with the cap and the resistor, and if that doesn't work, if that doesn't work, I'm not sure what we do, because I don't really want to spend another month or however long brainstorming fixes for this board. Been there, done that. I mean, it's a fair comment to say that there's far too much cabling in the machine, and it's absolutely correct. But how else are we going to get everything in here? The cabling has to be here, and the cabling is just about as short as it's going to get. Right, so this is SN74S08N from an 800XL, from my 800XL. It's just becoming really difficult to even get in here now. But I was encouraged to share my experience of Rapidus, and I continue to do so with this video. So we've replaced 74 LS08. Let's power it on. Let's put the Rapidus back in first, otherwise we're really not going to learn anything, are we? We're really not going to learn much if we don't put the Rapidus back in. I'm going to put my Rapidus back in. My Rapidus has been in and out more times than I care to remember. But I mean, it's more or less, it's just geared up to fail this because there's just too much stuff in it. appreciate that. Right, power it on. Do we get a boot? Yes, we do. And we now boot into, we boot into 6502 mode. Now I've seen this behavior before as well, and it's not good, because the machine would randomly jump between 65816 mode with a 65816 operating system and can you hear the heaviness in my voice? Can you hear the heaviness? The weight, the enormous But yeah, the machine will boot randomly into 65816 mode. I mean, it's an emotional quality. The sound's okay, but it's an emotional quality in the voice, you see, because the machine will boot randomly into 65816 mode, and or rather, it won't change modes. It'll boot randomly into the 65816 operating system and the standard operating system when Ultimate is present. This is exactly the behavior I observed with the first board and the second board, and it was a kind of a ROM selection issue, and it was fixed by the later firmware, or so I thought. Am I going to have to update the firmware on this board? No, I'm not even going to think about. No, I'm not going to connect a JTAG header to this board and update it. It's got to have the latest CPLD firmware on it. Don't make me start a virtual machine with Windows 7 on it and launch that USB programmer and have to solder a header on here and no. Alright, let's that's okay. Okay, so we're back in the Ultimate BIOS. The screen isn't flickering, and the keyboard works. And if we press reverse video and reset, we get into the Rapidus menu. Okay. And the keyboard works. Cartridge ROM's on. System ROM Rapidus. That's correct. So system ROM is Rapidus, so why is it booting into a standard operating system? Why? Save and exit. Now it boots into the 65816 operating system. But in fairness, since I swapped 74LS08 from my 800XL, where I already swapped that chip out and just got the machine fixed, it's a little bit better. So we go back into the Rapidus BIOS, we save and exit, and we're back there, and we press reset, and we press reset, and we press reset, and we haven't locked up, and we haven't jumped back into the standard operating system or rebooted, which is good. So if we power down again and power on again, and now we boot into the 65816 OS, which is what we want. So this is kind of working now. I recommend BIOS from FJC. Well, it's funny you should say that. Funny you should say that because I recommend that too. Yes, I recommend that one. I highly recommend it. And it has the advantage that you can turn the Rapidus on and off. So when it crashes, you can turn it off, which is really useful. So this is working now, but what am I going to do? What about my 800XL where I pulled this 74LSO8 chip off the board? Where am I going to get a 74LSO8 which works with a side cartridge? What about me? All my good spare parts end up in these machines. Alright, then let's press on. Let's just assume that it's going to work well enough. And let's press on. So, the next thing we do is let's try and go for another 20 minutes or so and see what we can get done. Yeah, what about my machine? My machine's fucked now because I've taken the good chip out of it. Oh well. Let's see if we can fit the stereo board. If we can fit the stereo board, I'm just gonna finish the video and what will we be on? Part 6? Part 6 of this series will be cutting a hole in the case and then trying to make sure the damn thing works. I mean, I haven't even attempted the side cartridge again. God only knows what's going to happen when that gets plugged in. But, alright, then let's test fit this stereo board and see what we can do here. And I think this ribbon cable is going to be better. I don't know. I'm probably going to have to... This is going to be a tight fit here. Let's see. I've got a funny feeling this isn't going to fit. Alright, let's put the first Pokey in here. It's just... There's a few connections to make and things to wire up, but I just want to get an idea of how things physically fit in the machine. Alright, so here's our Pokey stereo board. This is the last part we're going to put in. Well, nearly the last part we're going to put in. This is actually the last part. It's got to have this attached to it as well, but it's once that's in, that's everything. So we will push this in here. Alright, that's pushed in. Fits. Kind of fits. It's, yeah, fits. There we are. Right, so we're going to unplug this. Unplug this so I can move the board around so you can see what's going on. That's the whole point of this after all, so you can see what's going on. So there's the stereo Pokey board. Oh, look at this. Tight. Yeah. But it's all going to fit. Looks like it's all going to fit. So, let's proceed. Now the U-Switch has to go on this 6-way header here, and it doesn't fit. And it doesn't fit. That's awkward. That's a little bit awkward. Look at this. Right, you see this here? That board is soldered onto that header. Now I didn't put that header on there. That was already there. So that slides on the top of this. like so, and stand up. Okay, so that's got to go on there. But look at how it's sat on the top of that hearting connector. And worse yet, there has to be some wiring here and some header pins. By the time I solder the header pins on there, that's going to be an angle like that. That's less than ideal. But hang on. I'm sure Atari published a picture of a 800XL motherboard that he'd built, which had all of this stuff in it. It had Rapidus and Adaptus and VBXE and Ultimate 1 MB and stereo Pokey, I think. If only I could find that picture. If only I could find that picture quickly. You can see, well, it's on the other machine. I'm going to see if it's on the other machine, because I really need to see how he got that stuff to fit. How did he get this thing to fit? Not that. Not that. It was a while ago. Or did he post it in? Oh, did he post it in the Atari 8-bit? Did he post it in the Atari 8-bit group? He may have done. Let's have a look. Atari 8-bit computers. Let's see. May 18th, 21st of April. Chris Lucky, have you played your Atari 600XL today? He's fitted a Rapidus in. A 600XL with a VBXE adapter. Where is this photograph? Oh man. Atari 800XL Adaptus. Images. Is it on his website? I don't know. I'm not sure. Okay, point being, Adaptus is designed for the XL machine. It's not designed for a 1200XL. It may be designed for a 600XL. I don't know if it fits. It would be interesting to see if it does. I have a feeling. Let's grab a 600XL motherboard and see if this thing would actually fit. One I have lying around. So let's just do a quick visual inspection. I don't. Yeah, I think it would fit. Hang on. Well, wait a minute. to test this theory out before we do anything else. Take this off here, take this whole thing out. Right. Move you to one side. Right, here's a grotty old 600XL motherboard. Here is adapters. And there is no hope in hell, no fucking way that that's going to fit in a 600XL. So we can discount any hope of... The reason it doesn't fit is because of the keyboard connector, admittedly. So if we took this off, if we take that off, does it now fit? It just about fits. Yeah, so it does fit in a 600XL if you remove the keyboard adapter. But the keyboard adapter is supposed to be there, so I'm a little bit unhappy about that. But it would fit. Now, you're not going to be putting a stereo Pokey in with this. I appreciate that. The way I got Ultimate 1 MB and stereo Pokey to fit in this machine, the 600XL, was to put the operating system ROM slot at the back where BASIC used to be. You have to change some jumpers on that machine, but you can do it, and it makes everything fit. So let's forget about 600XLs for the moment and go back to this machine. And I've just dropped the mic, just dropped the transmitter. Hope that wasn't too bad. So let's forget about 600XL for a minute and come back to this. So put this back. So I've got to find this. If this adapter is designed for this machine, primarily for an 800XL, with the possibility of adding a stereo Pokey and a U-Switch at the same time, where does it tell you that you have to mount the U-Switch at a 10-degree angle? Did anybody encounter that before when it was being... If this was... If... Well, alright then, so it... what we're going to do about this, because that's not going to work. How about... So... This needs to be higher. I would say that this needs to be higher up, and then everything should fit. So how are we going to make this higher up? Some sort of standoff. Some sort of standoff. I'm still annoyed about having to put my 74 LS08 in this machine. Let's have a look, see if I've got anything that's gonna work. Fabricate anything that'll work or cut something down. What about these? This should work. This might work. This kind of thing that you see on the... Right. Okay folks, if you want to make a machine like this and you want to put a U-switch on your stereo Pokey board, you're going to need a standoff under the U-switch. I'm going to solder that in there like that, and hopefully that will plug in. Let's try it. Plug this in here and put this in here. How does that look? Ah, that's better. That works. So that's going to give us perfect. Perfect. Okay. Atari, if you're watching, you need to put that in your documentation, because this kitchen sink computers like this stuff doesn't fit. The ultimate 1 megabyte header on the adapters blocks the U-switch, and there's absolutely no way around it. So, and it's not because I'm putting headers or anything on the board, it's just I'm putting it together the way it was designed to be put together. So that needs to be highlighted. So let's solder this thing on. And everything should fit together quite nicely. What would do if the iron tip wasn't filthy. Better. I'll show you what that looks like. So if you need to make something similar to this, look at this cork board or something. I'm going to focus on that. Come on. Come on. There we are. So this is what I've soldered this onto the U-switch board. Okay. Actually, it's a bit better because it means that the U-switch isn't hard soldered to the Pokey board, but you've still got to pick 5 volts off the Pokey, so this should plug in here like so, and look at that. That's not so bad. That's not so bad. Ow! Ow, 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 ow. Just stabbed myself in the thumb with the legs under the board. Ow. Ow. Come on, focus. Don't say you're knackered already, camera. There we are. It's just like the focus is just... The focus is just... like me, it's just... oh. Ugh. Do I have to refocus again? Anyway, so that's what this looks like. So we're almost there. Ow, ow, ow. So, pressing on a little bit, we need to solder some headers onto this U-switch board, and we need to pick off a couple of signals for the stereo board. Let's solder these headers on. Oh, I keep grabbing this board by the corner and it pulls the Rapidus off the board. Okay. Okay, let's do a little bit of solder some headers on here. I'm going to make yet another header for the 5 volts and ground. Yeah. More crimping required. So we're gluing. I've been doing this too long. We're soldering the header onto the U-Switch board. And we'll put it back on the board, make sure it all fits. Then we'll find out where we're going to pick off A4 and bell and anything else we need. So the binary signal comes in here. This is far too long, this wire. This is our MO signal from the Ultimate 1 megabyte. MO from the Ultimate 1 megabyte, and that goes onto the end. This is not sturdy, but never mind. It's not my fault. That goes in there. And stereo audio is going to plug in here. Oh, fuck. Oh. Push you down. Hopefully I'll be able to plug this in. Yeah, that's tight. We forgot to add the Wi-Fi board. Damn! Oh, I knew I'd forgotten something. I knew I'd forgotten to put something in. The damn Wi-Fi board. Right. So I need 2 wires going to VCC and ground, and I need a jumper. I already got a jumper. Here's a jumper I prepared earlier. Which position do we put the jumper in? I think it's position 1. Alright, so this jumper here, if you can see it, because the camera's just given up trying to focus completely. Yeah, this jumper, if I remember correctly, it's just a reverse the logic. So if this signal is low, let me get this right. It reverses the logic anyway. So if you want the switch to be on with the signal low, you put the jumper in the opposite position. If you want the switch to be on with the signal high, you leave it in that position, or vice versa. It's one of the two anyway. But additionally, in the BIOS, the newer BIOS, you can have binary switch options on the screen that have the logic reversed in software as well. So you got 2 opportunities to reverse the logic. And we need VCC and ground. So have I got some more wire? We're going to pick VCC and ground from the bottom of the Pokey board. And that will... oh no, it won't. Where did I pick A4? Ah, that's where I picked A4 from. Fifth pin in and the bell. Right. Okay, I see. Right, I think I know what I'm doing. We need to get back in underneath all this lot. Again. So we need to pick off E4 and bell for the stereo board. And I'm going to use these wires right here, which I prepared earlier with crimp connectors on them. And we're going to cut a wire which isn't too long. Turn the wire. Double check. I'll put the thing in the right spot. Yep. E4 happens to be on this wire here, just next to the OS-ROM socket at the back. And this is a convenient spot to pick it up for the Pokey chip. It's jumped out of the hole. Get back in there. Right. Okay, there's our A4 wire, and I now want the bell signal. The bell signal is right the way over the other end of the board, which it would be. It's at the bottom of a capacitor. I'm going to need quite a long wire. How long exactly? So it's going to go here to here. That should do. So I've got a wire which is suitable length for my bell signal. I'm going to tin my bell wire. After I first twist it. this is the last wire that we have to apply, just in case it appears that there's been very little progress made. This is the last wire that we have to attach to the board, aside from chroma and composite sync for the RBG or GB jack. But aside from that, it's the last wire we have to attach to the board. Props for making this antic adapter tighter in the socket. It's very good. I used to jump around all over the place, but not now. Let's disconnect all this. But see how nice it is when everything comes out. Just pops right out. Pops right out of the board. Now, which is the capacitor, which has got the bell signal on it. Walk back over the room to the reference board, and it is C23. C23. The bottom leg of C23 has got the bell signal on it, which is this capacitor here. This one here. So I'm going to solder a wire to the bottom of there. And that will be the bell signal for the Pokey board. Right, that's secure. That's good enough. So we'll put our VBXE back in the board. Reattach all the connectors. Did I say put this on last, didn't I? Yeah, I did. Push this down. Plug this in. So there's the bell signal. There's the bell signal, and this is the, what the fuck is this? That's the stereo signal. This is the A4 signal. So we need a little three-way DuPont connector. Bell is the second one along. Is this gonna fit? Yep. A4 is on the right, so we'll plug this in here. And that's our header done, and should be able to plug everything back in here. They need to be above this ribbon cable. Yeah, and this needs to go in here. There's our stereo signals. And the final step, and that's the switch for U-Switch. The final step is to get 5 volts and ground for the U-Switch, which won't take us but a moment. I'll make myself a little cut down connector. Might as well make it plug in, everything else plugs in on this board. We'll just go totally crazy with the plugging in. Right, there's our connector. And where did I rig up the wiring? Let's have a look at the bottom of this one. I'll work from this one, which is mine, for speed. Just once these two wires on, we're done for the night. How long do these need to be? Oh, I was going to do Brian's quick and simple video mod for the 800XL as well. It would have been a good idea to do that before I put the Ultimate 1MB back in the board. Do that in the next video. Who's this? Who's here? Oh yeah. Right, VCC and ground. So VCC is this one. VCC goes to there. You're going to go on this pin here, aren't you? Yeah. Yep. Got to get this right. Get this the wrong way, I'll blow the U-switch up probably. Alright, that's on. And ground over here, about that long. This is our ground wire. Get on there. Tin U. Tin U. Right, that's it. Get rid of this. board back on the desk. We now have all the signals needed for the Pokey board and the U-Switch board, and we should get a light on the U-Switch board when we switch the system on again. This is so we plug in E4 and bell, and we plug in left and right audio, which I'm going to do a damn thing yet because they're not wired up to the RGB jack, and this is ridiculously tight fit. And the MO signal from the Ultimate 1 megabyte plugs in there, and we just yes, tidy this up later on. So we are a long way from being sure that this machine is done and working in a satisfactory fashion. A very long way from that. Plug in our Ultimate 1 megabyte signals. Crikey. See if you got lights. Yeah, boots, lights up. Oh, full of surprises, this machine. Full of surprises. So as you can see, this is not done by any stretch of the imagination. Let's boot it into the right operating system. And it's encountered a problem. Well. See the light? Oh, you can't see that. Yes, you can. There's our light on the U-Switch. Fatal ROM cartridge change detected, system halted, press reset reboot. That's bullshit. I haven't plugged anything else in. I wonder if it'll work with this Uno cart. I wonder if it'll work with this Uno cart. This Uno cart, which you can buy from me when I produce another run. Let's have a look. Loading core. Give you a better look at that. That's our Uno cart menu. Version 2 of the Uno cart menu. Insert keyboard, baby. Yeah. Why not insert the keyboard, because it did help before. No. Yeah, we'll give it one more try with the keyboard. We plug the cartridge in. And see what we get. Okay, that's enough for one night. That's enough for tonight. So, as promised, we fitted the VBXE tonight, which now supplies the master clock for the whole system. We installed the stereo Pokey and the U-Switch, which all work, and in the next video we will wire up the RGB jack, and try to diagnose what is wrong with the stability of this machine, only when the Rapidus is present, and hopefully get it all fixed. There's someone creeping up the stairs. Okay, so thanks for watching, and I hope you enjoyed it, and until next time, bye bye.